The Ohm's law in simple words gives us the relationship between the current, the voltage and the resistance in a circuit. This tells us that the flow of current is directly proportional to the potential difference between the points and inversely proportional to the resistance. If the potential difference between 2 points is more, the current flowing through it will be more. And if the resistance is more, the current flowing through it will be lesser. This is assuming that the other factors are constant. Let's do a quick activity to understand Ohm's law. We would need a nichrome wire, a voltmeter, an ammeter, and 3 electric cells of very low voltages, somewhere in the range of 1 to 1.5 volts. First, we form a circuit like this which has just one cell as the source. This is the nichrome wire, which is the resistance also. This is the ammeter, which is in series. This is the voltmeter, which is connected in parallel. And this is the plug key. We close the plug key and note down a few readings. We need to note down the reading in the ammeter and the reading in the voltmeter. Let the current and the potential difference be I1 and V1 respectively. In the second case, connect 2 cells in the circuit and note the respective readings of the ammeter and the voltmeter. Don't forget, the ammeter gives the value of current through the nichrome wire and the voltmeter gives the potential difference across the nichrome wire. Let's say the readings are I2 and V2 respectively. And then repeat the same procedure for the third case when 3 cells are used as the source. You will notice that as the number of cells increases, the current as well as the voltage increase. But are they increasing proportionally? To know that, we add an additional column at the right which calculates the value of V over I for each case. You will notice that the ratio of potential difference to the current in each case will approximately be equal. This tells us that the potential difference V across the ends of a wire is directly proportional to the current flowing through it. This relationship was discovered by a German physicist, Georg Simon Ohm, in the year 1827. Notice that the resistance here is constant and we also assume that all other factors including temperature are also constant. This is the Ohm's law. If V is directly proportional to I, it also means that V over I is constant. And that constant is nothing but R or the resistance. What is resistance? It is simply the property of a conductor to resist the flow of charges through it. Here in this experiment, it was constant. The SI units of voltage and current are volt and ampere respectively. But what's the SI unit of resistance? It's ohm and is represented by this Greek letter. If the potential difference across 2 ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance of the conductor will be 1 ohm. In the next video, we will look at another interesting experiment to understand the Ohm's law.